Hi there, in this video I'm going to be talking about vector projection. So we have two vectors here, vector A and vector B, angle theta between them, and we want to find the projection of A onto B, which is going to be this vector here. Let's call it C. And we say that C is the projection of A onto B. And you can think of it as the shadow of vector A created on the line created by vector B. So if there was a line created by vector B, the projection of A onto B is this shadow over here. So how can we find vector C? Well, any vector has magnitude and has direction. In fact, you can think of any vector as the magnitude of this vector multiplied by a unit vector pointing into the same direction. So if we find the unit vector pointing into the direction of C, then we find the magnitude of C. We in fact found the vector C. As you can see here, vector C points into the same direction as vector B. Therefore, a unit vector pointing in the direction of vector C is vector B divided by its magnitude, which is B hat. And that's the direction. Now next thing we want to find is the magnitude. Well, if this vector over here has magnitude A, then this vector has magnitude A cosine theta. And that's just from basic trigonometry. If this side has magnitude A, then this side has magnitude A sine theta, and this vector has magnitude A cosine theta. We also know that A dot B is equal to the magnitude of A times the magnitude of B times cosine theta. Therefore, cosine theta is equal to A dotted with B divided by the magnitude of A times the magnitude of B. If we substitute this into this over here, we can say that the magnitude of C is equal to the magnitude of A times A dotted with B divided by the magnitude of A times the magnitude of B. And this cancels with this, and we end up with A dotted with B divided by its magnitude, which is B hat. And that is the magnitude. Therefore, vector C, which is the projection of A onto B, is equal to A dotted with B hat times B hat. And that is the general formula for vector projection. Okay, so let's play around with this formula. Let's say we have that vector over here is 2A, and we have vector A, and we're trying to project these vectors onto vector B. Well, you can see here that the projection of A onto B is going to be this vector, and the projection of 2A onto B is going to be this vector. Sorry, this should be... So if we increase the magnitude of A, we're also increasing the magnitude of the projection. And this makes sense into this equation, because if we scale A by 2, then we have to scale C by 2 as well. So changing the magnitude of A changes the magnitude of the projection. However, if we increase the magnitude of B, so let's say this is vector A, this is vector 2B, and this is vector B, the projection of A onto B is going to be this vector over here, which is also going to be the projection of A onto 2B. It's the same vector. So changing the magnitude of b wouldn't change the magnitude of the projection. And this also makes sense into this equation, because in this equation we're only using the unit vector b, which is b divided by its magnitude. So it doesn't really matter what's the magnitude of b, because we're always going to use the unit vector which has a magnitude 1. I guess that's all I want to talk about for vector projections. In the next video I'm going to be solving an example that involves vector projections. And if you have any questions, please leave them in the comment section below and I'll be more than happy to answer them. Good luck.